Let's learn the basics in translating English phrases into algebraic expressions and vice versa. One of the essential items or concepts that we need to master before we could proceed to solving algebraic expressions is how to in translating a situation or a real life problem or even a sentence into an algebraic expression and even vice versa. That's part of our analysis because if you commit errors or mistakes in translation or in translating them, definitely whatever you do in your process will be incorrect. Let's try to talk about two items here to be translated. And then we also have other expressions here, and let's try to determine examples of their translations. Now, for number one, the first group rather, need to determine the equivalent algebraic expressions given these English phrases here. So in the technique in translating English phrases into algebraic expressions is to understand the keywords that determines the operation. And then from that, let's try to analyze further which is which and which should be which operation should be the first one to be considered or vice versa. Let's talk about number one. A number less than the product of 4 and W. We have two sets of keywords here that actually pertains to an operation. When you say less than, do you see this notation? In our elementary years, we have learned that that is less than symbol. Let's say 3 less than 5, right? But actually, it's not less than. This symbol is not less than. This symbol is actually the symbol for less sorry is less than. It's not less than, okay? It's is less than. So we properly read this item here in our elementary years. 3 is less than 5. Okay, and the other way around, of course, the other symbol, the symbol is read as is more than or is greater than. Not just more than, not just greater than, but there is a verb is. Okay, my point of sharing that is to make us understand that this keyword is not for this symbol. That keyword is actually for subtraction. Okay, this keyword is for subtraction. And of course, when you talk about product, it's the result when two terms or numbers or expressions are multiplied to each other. So it's a process of multiplication. So we have two operations here: the subtraction and then the multiplication. But which should come first? Let's look at the situation. We have here a number k. We use a capital letter K here, so let's stay as capital letter K less than the product of 4 and W. Before we could just say minus here, let's try to talk about the product of 4 of W first. The product of 4 of and W is not exact since one of which is a variable. So we just simply need to write them into one using the operation of multiplication. And in algebra, we just simply need to write them side by side. This is for W. Some of you might use parentheses, but since there's no need for that, since it is already um, under multiplication, so it can hold as that. Is our final answer K minus 4W? Some of you may say yes because there is the term of less than here. So it just simply follows the left to right pattern. A number K less than the product of 4 and W. But however, there is an important catch for subtraction keywords. This is not a problem for addition, but in subtraction, there is a catch. This is actually same as when you say 5 is subtracted by 2. So it's 5 minus 2. But if you're going to interchange the one of the word there by to from, 5 is subtracted from 2. It's the other way around. 5 is subtracted from 2. This is its form, because in subtraction there are catches in the keywords, and then these two expressions are not the same since there's no commutativity in subtraction. This would mean that if we talk about subtraction operations, just like in number one, we need to be vigilant on the correct operations. My point here is this: it may look like this algebraic expression, but the term less than is different from the term less. Right? Less. The term less than is actually the same as the with the expression or the keyword using the term from. So it's by when you say from, just like this group here, 5 is subtracted from 2. It's the other way around. The first item that was shared is not the minuend or the first number in the subtraction process. It's the second. And the last one, the latter, will be your minuend now. In short, when you talk about less than, this is not the correct form. The correct form is this one. When you say less than, interchange the two terms, you will have 4W and minus the capital letter K. This is the form for number one because this is the catch for the term less than. So what is actually this expression here if this is not correct? This is the translation if there is no than word here. Let's just say a number k less the product of 4 and w. When you simply just say less, it's just the way we write it from left to right. This is the expression if the given is less. But since the given is less than, let me just remove this for that so that there will be no confusion. The correct form is this. Okay. So you simply need to analyze that one. Number two, we have here the expression twice. The sum of x and 1 is 14. We need to identify the keywords that represents operation. So first, let us talk about the term twice. Twice is actually a unique keyword for multiplication, specifically by a factor of 2. When you say my age is twice as yours and your age is 10, my age is 20. If I will say my allowance is twice as much as yours and your allowance per week, say for example during face-to-face classes is 500, then I have twice as much. That means I have 1000. So twice is the keyword for multiplication. Of course, the term sum is for addition. And then actually that is what could represent now this group here. How about this is? Is a be verb. Specifically in mathematics, that's actually for equality or equation. So this is the keyword for equal. So what would be the expression for number two? Let's look at this one. We don't have operation for division nor subtraction. Those two operations do not have commutative property. So if we don't have those two, then it's just simply safe for us to look at this from left to right. So twice. You have here twice, again, a factor of 2, the sum of x and 1. Is it safe to say an expression like this? You simply need to repeat in reading or looking at your term. If you're going to write it this way, this is twice x plus 1, or the sum of twice x and 1. What makes this different from the original statement given is that in the original given, it tells us that we are doubling, meaning there's a factor of 2 to the sum of x and 1. This means we start first with the sum of x and 1 and twice it or double it. This means there is a grouping symbol here that represents the sum first. This is not the correct way in writing twice the sum. because again, the other way around could be read as twice x plus 1, or the sum of twice x and 1. But here we are doubling or getting the twice of the sum. So this is twice the sum as a whole. We're treating the sum as 1. We are not yet done because there is the notation here for is. We use equality, and you have here 14. So this is now the expression that is actually equal or the same or correct form for the translation of twice the sum of x and 1 is 14. Again, is equation or equality. By the way, you don't need to answer this first, as we are not yet checking or answering the linear equation form here. We are just still on translating. So I gave you these two items just for analysis, but we also have other examples here. But for the rest of the items here, we are now tasked to give equivalent English phrases. For the first group, given an English phrase, there is only one exact algebraic expression. As I mentioned, this for number one and this for number two. No negotiations about them, because when you talk about algebraic expressions, they must be the representative of how the English statement or phrases are being mentioned. But if we talk about the algebraic expressions first and translating them into English phrases, since we have plenty of keywords per operation. You have, when you say addition, you can say plus, sum, total, increase, more than, exaggerated. And then we talk about subtraction. We also have many keywords, as well as multiplication, division, and even the equality. So we cannot actually expect one answer here. But let's me give you one of the basic examples. For number one, let's look at the term here. We notice that there are two terms separated by subtraction. So you could start with that. You can say here the difference, as this is the symbol for our keyword for subtraction. The difference. What are you get? What are you? What terms are being or what are the terms under this difference? You have the term here 5b squared and then 1. But do not say the difference of the symbol, the expression 5p squared and 1. Why? Because you also need to express the operation for this one, the this two here. Because you can just simply say 5p squared and do not declare its operation separating them. So this would mean this is not yet correct. What you could do here is this. Take note that the operation separating 5, the coefficient of 5 and p squared is multiplication. So you could say here the difference of the product. Let me use the text. The product product of 5. And now if you talk about exponentiation, you have many terms. You could have raised to p raised to 2, or you simply use the p squared. We'll have here the difference of the product of 5 and p squared and 1. That's one example here. How does it look like? It tells us that there is a difference. And what are the terms under this difference? The product of 5 and p squared. You have here 5 and p squared and then 1. That's just one example. You could also go with this. Okay? The product. You started with the product of 5 and p squared, or uh, squared. Okay? Because squaring is a special term keyword for exponentiation. You cannot go wrong with that. So the product of 5 and p squared, we are starting with the first term and then pair it with the other term. Since it's minus, you can say less 1. The product of 5 and p squared less 1, Or if you don't like that, you could also say the product of p squared subtracted with 1. You cannot pick a specific answer here because there are many keywords that represent the operation. These are just few of the examples. In number 2, I could give you the basic or the easiest. Y plus 3 equals -1. You don't need to make a word for negative. You can just simply look it as a coefficient of -1. This is the easiest form. Y plus 3 equals 1. Simply just you're just similar to reading the expression. Or you could say the sum of y and 3 results. That is another term for equality. Results to -1. Or you could go the other way around. -1 is um, is equal or is equivalent. Let's do this. Equivalent when, okay, I'm just making it fancier, when y and 3 are added. So you could have that form as well. As for exercise number 3, here you have an expression. The general form is actually for division. So you could go with that. Okay, you could go with the division, and you could say the quotient of, and then you declare the numerator and the denominator. The quotient of the difference of twice x and 3. We're talking about the quotient of the numerator, which is difference of twice x and 3, comma, and 2. This would mean this is the quotient of the difference of twice x and 3 and 2. If you don't like that, of course, you could use other forms. You could have here, some of you would like to say the quantity of twice x less 3. Why do we use quantity? Okay, I'm going to explain it later. Huh? The less 3 is divided by 2. When you say the quantity of twice x less of 3, you're taking the twice x less of 3 as as a one singular group that can be found in the numerator. Because if you're not going to use the word quantity, you will have, you see here, twice x less of 3 is divided by 2, right? So you could have here twice x less 3 divided by 2. Some of you might have that one. So it's better to declare grouping as a quantity. Or if you don't like that, you could also say it like this: half as the notation for division of 2. Because when you have division of 2, that means you're having whatever expression you have. Half of the of twice of the quantity of twice x plus 3. Again, there are many possible forms here. The thing that you just need to be reminded of is whatever you have translated, you try to go back, revert the process if you are going to reach the given. So there are many forms here, and I would like you to try as many as you can. This is the pre-break session for translating expressions. See ya.